Good morning, students. Today we are going to deal with the topic simple pendulum. A simple pendulum is a device which contains a heavy point mass called bob suspended from a rigid support by an inextensible and massless string. Its effective length is taken from the point of suspension to the center of the bob. So, when a bob is at rest position in a straight line, we refer it as its mean position. When the bob moves from its mean position to the extreme right, from the extreme right to the extreme left, and finally back to its mean position, it completes one oscillation. The next topic is time period. The time taken to complete one oscillation. It is denoted by the letter T and the SI unit is second. Next topic is frequency. Frequency of an oscillation is the number of oscillations made in 1 second and it is denoted by the letter F and its SI unit is per second or sometimes we denote it as hertz. The length of a simple pendulum is the length from the point of suspension to the center of the bow. So now let us see the relation between the time period and the frequency. As we know, time period is the time taken by the simple pendulum to complete one oscillation and it is denoted by the letter T. And frequency is the number of oscillations completed in 1 second and it is denoted by the letter F. And therefore we conclude the relation between them. F is equal to 1 by T. So now let us see how to perform an experiment of a simple pendulum and find out how that time period varies with the length of the pendulum. So first of all we have to suspend the bob by a perfectly inextensible and weightless string. Then measure the length of the string from the point of suspension and to the center of the bob. Third, gently pull the bob pendulum from one extreme in such a way that it moves from one extreme position to the other and back forth its first, thereby completes an oscillation. Now take a stopwatch and record the time of a pendulum takes to complete one oscillation. Fifth, the time period of the simple pendulum will be the time taken to complete 10 oscillations divided by number of oscillations. Repeat the process with different lengths of pendulum. 7. Plot a graph with time on its x-axis and length on its y-axis and you will get a curve graph. From this graph, we infer that the time period varies with the length of the pendulum. So dear students, now let us look into the slope of t square versus L graph in the basis of simple pendulum. In a simple pendulum, we know that time period is dependent on the length directly. The time period of this is directly proportional to the square root of its effective length. That is, T is directly proportional to square root of L. You can look into the graph where we plotted L on its x-axis and T on its y-axis. Okay, so the acceleration due to gravity or the G can be found out from this above mentioned graph. To find out the slope of the straight line, we have to first point 2 points on this straight line, that is P and Q. Then the value of the t-square can be noted at the point A and B. And to know the value of the L, consider the points C and D. So that now we got two different points and it is become a straight line when you join the lines, and the slope is found out by doing AB. And AB is equal to AC by BC, or we can say that T1 square minus T2 square by L1 minus L2. The slope is observed to be a constant at a point which is equal to, we can say, 4 pi square by g, where g is the acceleration due to gravity. Hence, g is equal to 4 pi square by the slope of the t square versus L graph. Or therefore, hence g can be determined with the help of this measurement in this relation. Now we are going to see the factors affecting the time period. The first one is the time period of the oscillation of a pendulum is always directly proportional to the square root of its effective length. That is, t square is directly proportional to L, or otherwise we can say L by t is a constant. The second one is the time period of an oscillation of a pendulum is inversely proportional to the square root of the acceleration due to gravity. That is, t directly proportional to 1 by square root of g. The time period of the oscillation of a pendulum does not depend on its masses and the material of the body suspended. Finally, the time period of the oscillation of a pendulum does not depend on the extent of its swing, that is, the amplitude on the either side. Now, let us try to see the expression for the time period of a simple pendulum. So far we have tried to understand the time period of an oscillation of a simple pendulum is given by the following relation. That is, t square is equal to 4 pi square L by g. This is the standard form, where t is the time period and L is the effective length of the pendulum and g is the acceleration due to gravity. At a given place, since g is a constant, the time period of the simple pendulum of a given length is constant. This is why pendulum can be used to measure the time. Now let us see what is seconds pendulum. A seconds pendulum is nothing but a pendulum of clock which we use to note time in our house is also considered as seconds pendulum, because it takes 1 second in moving from one extreme to the other extreme. So its time period is 2 seconds. A pendulum with period of oscillation equal to 2 seconds is known as a seconds pendulum. The effective length of the seconds pendulum at a place where g is 9.8 meter per second square is nearly 1 meter. So I hope so far it is clear about the simple pendulum. Thank you.